So this video is going to be about the involutes and evolutes of certain geometric shapes. So as you can see here, we have a square and a triangle. So we can involute now is the unwrapping of the points, as it would, to go around the shape. So for a square here, it would be a simple. The square is 40 centimeters long, so we can, the first point here would go to 40 centimeters long, and then this would be the first wrap of the circle here. Our next one then would be 20 centimeters long then. Like as we go along here, be 20 centimeters long, or no, 220s I mean, or 240s, so it'd be 80 centimeters long. One after that would be 120, and then the final one would be 160. So you can see the circles that they would generate and the paths they would create here. You can see that they would follow the outermost path of these. So from here, then moving on to this one, then moving on to this one, and finally the last one to here. What I've done for this in the question is that I have given each of these certain colors. So you can see that this light blue and this light blue here, this would be the first circle, and then we should move on to the second ones here, where it'll be slightly darker and the light blue again, slightly darker and the light blue. Next one, third one getting even darker now. So I'll have the three points, 3 lengths here, and then finally we'll have all 4 of the sides shown here. This would make a shape like this, so you can see that it lines up with the radiuses. So the path of a piece of string, it would take its own round around the square. The distance at the apex of the square is equal to the length of the string at that point. So these 2 lines here are the same length as these 2. Now for a triangle, we will be just continuing on the angle. So as with a square here, we move straight down, we'll be continuing on. So this is 40 long, it'll be 80. This will be the first circle here now, like that. Next one then, and finally so the paths the circles would create are here. So this would be the largest one here, then move on to this radius, and finally this radius. So it'll start at this point and unwind down, then onto this one, and finally up here till it reaches this line here. You can see that I've done the same up here. So you have the same lengths that they create and how it's unwinding out. So all we're doing is continuing on the angle generated from the last vertex. The last thing about this topic here would be the circle, in which we would split it up as we've done before into 60-30s. This is only half of one, and then we would take a tangent at each of these points to find the length. So this would be the length of the first one here, then we move on to both of this one and this one together for up here, here, so we can move around. We're just generating a tangent at each of these generator lines here. So on the third one here, you can see that it's going straight up vertically and horizontally and taking the three distances of brown, orange and yellow. So then yellow, orange and brown here. So this is what I've created to help show the principles of the involute, and that's how the principles work as well.